Welcome, everybody. Hopefully you're enjoying the conference. Are you enjoying the conference? Yay. Who is enjoying the 30-something degrees, gigantic humidity, and the willingness to die? Yay, so do I. I mean, I shouldn't complain because I'm from Poland and we also have very hot weather there, 20 degrees, mosquitoes, and we love it. I should definitely change my profile picture because it's like from 10 years ago when I was young. Now I'm not young anymore. Yeah, that should change. Anyways, thank you so much for joining my session today. There's a lot of people here, so if they're like fewer, I still would do it. I have to definitely take a selfie with you. Okay, so everybody says spring. That's a lot of enthusiasm. Typically it's like spring. So yeah, thank you for being so enthusiastic. Maybe it's the topic, observability. So the title of the presentation is To Production and Beyond Observability for Modern Spring Applications. I'm a firm believer of something which is called no code, because if you have no code, there are no bugs. So everybody should be happy. On the other hand, we wouldn't have any jobs. So let's migrate that term, and today I'm going to be the believer of no slides. I have no slides. The only slide-like thing is my ASCII doctor slide over here. So yeah, let's start about me. So my name is Marcin Grzejszczak. Since I'm abroad, I can tell this joke that I know that it's impossible for you to pronounce my last name. Don't try to do it. You can break your tongue. Impossible. So I work at the company called VMware. Who heard about VMware? Quite a few people. Who knows that VMware is sponsoring Spring? Who has heard of a Spring framework? Okay, we have to do much better with marketing, much better. So VMware is sponsoring Spring. VMware equals Spring. So you can find me on Twitter, @mgrzejszczak. Yeah, I made a mistake. That wasn't a good idea to take the full name in the Twitter handle. I'm there at Mastodon. Who uses Mastodon? Nobody. Great. So you can find me there. And the handle is too much coding, so I fixed this problem. But you can go to my blog, toomuchcoding.com, and you can find all the handles over there. So what do I do at the Spring team? I work in basically two teams. One is the Spring Cloud team, where I lead the Spring Cloud contract project. Who is the Spring Cloud contract? Okay, 2 people. Great, great. It's more than 0. And I'm still running Spring Cloud Sleuth. Who is the Spring Cloud Sleuth? Okay, 4 people. That's twice as many. So now I also work at the observability team. So Micrometer, Micrometer observation, Micrometer tracing. So I've been doing libraries for the past almost 10 years. So let us just now imagine that I'm writing business apps. So those who know me would start laughing that, hey, you in business apps, but that happens sometimes. So let us imagine that we're going to be brewing tea. So we have a tea service on the edge. That's the best I can do with graphs. Sorry about that. So we have a tea service at the edge that is going to send 2 requests, one to the tea leaf service that itself is going to communicate with a database, and also to a water service that also is going to talk to a database. Now, what are the characteristics of these apps? All of them are using Spring Boot free. Who uses Spring Boot free? Okay, and Spring Boot 2? Oh, that's more. You should migrate. So Spring Boot free, and the fact that we're going to be seeing observability today, metrics, traces, log correlation, is all done thanks to Micrometer observation, about which we're going to talk a little bit later. Now, Micrometer observation works on the basis of certain handlers. So the handlers that we have picked for today is metrics plugged in via Micrometer core, and tracing plugged in via Micrometer tracing. So the tracer that we picked for today, a tracer is a library that handles the lifecycle of a span, is OpenZipkin Brave, but you could pick OpenTelemetry. So that doesn't matter. It's an implementation detail. From your perspective, just know that we have observability turned on, and we're going to have metrics tracing and log correlation. Now, poor man's version poll. Who knows what distributed tracing is? Raise your hand. Okay. Not that many people, so I will be quite, I will explain this a lot. And who is using observability, whatever that means, in production? Okay, more people, good. So at least metrics, I guess. Okay, so enough in terms of talking. Let's check the tea house application. Voila. So this is 21st century UI. This is the best. I didn't even do it. It's my friend Jonathan Ivanov that created this fancy, fabulous UI. And the best thing about this UI, because we are using the latest and greatest tech, is that it is responsive. Who is using the responsive, reactive UI stuff? Okay, quite a few people. So it's reactive because it reacts to my clicking like this. You can see that we can pick stuff from the combo box, and we can brew tea. So here we have green sencha. There you go. Fantastic. There was no table, now there's a table. So you can see to the bottom that this is how you should steep 300 milliliters of sencha, right? Fantastic. So let's pick something else, gyurka, for example, and make it medium. There you go. It changes because it's reactive. Now, let's try to do the English breakfast one. There's like around, I don't know, more or less 300 maybe people here. So let's pick the large one. So everybody's going to have 1 milliliter of tea. That's good enough. And that's the... Oh. Okay, let me click again. Okay, I clicked 10 times. Let's refresh the page. Let's refresh the page. Let's do it again. Okay. That's unexpected. Internal server error. I wonder what that means. Maybe an error that happened on the server side and it's internal. So that's most likely the case. Okay, I think that something is really wrong. It's not my browser. We have to think of how to solve this. What we could do is, and don't be shy, we're friends here. What we can do is SSH to production and grep for logs. Who does it like this? Don't be shy, don't be shy. Okay, quite a few people. So this session is for you. Don't do it. What we're going to do is we're going to go to our observability platform. By the way, today's presentation is not... Oh, I have to change it to the white thing, if I remember how to do it. Wait a second. Preferences. Light. Let there be light. Save. Is it better? It should be. Okay. So by complete accident, I have pre-prepared dashboards related to observability of our T application. So to the top left, over here, we can see the T-service latency. So we're looking at the T-service app, the one on the edge. So we can see that the latency is around 34 milliseconds. That's pretty okay. Like, looks reasonable. Here we have throughput. So we have around 4.6 of a request that is successful and like 0. something of server errors. We also have various combinations of steeped tea, so whether it's large, small, the type of tea, etc. And to the bottom, we have heat maps. Here we have heat maps, so we can see in which buckets do the requests lay in terms of latency. So we have, for example, a bucket here between 28 and 33 milliseconds. All the buckets are within the range of 8 to 30 milliseconds, so everything seems fine. So what sounds sad is the fact that we have those errors. So let's try to think about this, like what could cause the error? So here we are in the metric side. So what I'm going to do right now is I will explore and go to the part of the system that corresponds to aggregating logs. Now, this presentation, this whole demo, is not about the Grafana stack, because I'm not an expert in Grafana. I had to pick something, right? The idea is, of this presentation, that we have the 3 pillars of observability, so traces, metrics, and logs, but themselves, it's useful to have them, but the best outcome is to work between them, to jump between them, to see correlation between them, and that way reason about the whole thing. So what I'm going to do here is I'm going to search for the error logs. Let me do it like this. Now let's refresh this. Okay, so we have quite a few error logs, so that confirms what we have visually seen on the metric side, that indeed there's quite a few metrics. Now, those logs, now for those who don't know what distributed tracing is, the idea of distributed tracing, in essence, is that when over here we're brewing tea, we get one request coming in, and it pops out like 2 additional requests in the system. So let us assume that all those hops between services are propagating an identifier, the same identifier for the whole life cycle, the business life cycle of this request. That thing is called a trace ID. That identifier is called a trace ID. Why do we need that? Because then you can search for all the logs from all the apps that correspond to the same trace identifier. And that way, no longer do you have to SSH to different machines and copy the logs and search for the particular line, because the logs are aggregated in one place. And what you can say is, give me all the logs corresponding to that business operation and put them even in a chronological order. So now if I click on one of the logs, it says here, resource not found, name English breakfast. That rings a bell. We clicked English breakfast, so most likely this is related. And if we scroll down beyond the stack trace, we see the trace ID. Okay, so what is that? So when we click on this, we will be able to tell the observability system that, hey, show me the whole trace view. Now, what is that? Okay, let's check it out. So let me close the logs. Close. Now, what you can see here is the whole flow of the request in this T system presented in a visual way. So here we can see that, let me actually show you that in a bigger format, that the processing took 21 milliseconds. We had 3 services there, so T service, water service, and tea leaf service. And the whole operation, like I said, took 21 milliseconds, so it's over here. Now, each of those bars represent a span. A span is just an operation. And depending on how your instrumentation looks like, you can have various different spans. In our case, we have a span on the server side, the span on the request side, the span on the client side, the span on the server side, but in the water service. Then we have a span for the acquiring of the database connection, running the query, and getting the results set. So you can say that the span represents, let's say, measurement of a certain operation. You can logically, let's say that it's pretty much the same as a timer, right? However, the span has more metadata. What else I can show you is that here you have a node graph, a very nice thing, that shows you visually how your communication looks like from production. This is how it looks from production. So there was a T service, server side, client side, water service, server side, connection, query, and result set, right? So that's really nice. Now, let's try to figure out why we had a problem. So we have an exclamation mark over here, which says, hey, there was an error. So if we click this, we can see that we got the resource not found. Tea leaf with name English breakfast. Now what we can do is search for all the logs from all the apps, and now let's show the oldest first. So I know that this is like the resolution is kind of too big, but to the right you can see all the logs corresponding to this particular trace ID in time. So you can take a look to the left at the trace view, reverse engineer why the problem was there, and also you can get some support from the logs. So this is great because you have 2 dimensions at the same time, logs and traces. So let's focus on the traces. Let me close this one for the time being, if I know how to do it. Okay, close. There you go. So we got an error on the server side in the T service. That's quite expected because we've seen that. But is this the reason for the problem? Let's check out further. So we have the connection over here, and this is the first database span. So it says a query. So if we look at the attributes, we can see the database name, the parameters, so we can see the whole select query. Which is fine. I mean, I'm not an expert in SQL, but it looks fine. Now let's look at the result set. JDBC row count equals 0. That's unfortunate. So as far as I understand, we were looking for an English breakfast tea, that is not there in the database, right? Because we got results set having row count equals 0. So that's unfortunate. How can we try to fix this? Believe it or not, but I have a prepared HTTP request that adds the missing English breakfast thing to the database. So let's see if I run this. We get status 201, fine. So it seems that we got something added. And let's get back to our dashboard. Okay, so now what we expect, because we have our clients using our app, that over time, and hopefully that time is going to be pretty fast, we will have this equal to 5. Now, don't look at what I'm doing, because you should not be seeing this. Oh, okay, nothing happened, nothing happened. So let's look at what we could have done to prevent this, because it's really not like an ideal situation that, of course, it never happens in your applications, in your companies. But it's not an ideal situation that one of our customers says, I think your app is down, right? I mean, I think we should tell them, hey, our app is down. It, of course, never happens in your case because you have a lot of metrics, alerts, right? You have those, right? Okay, I believe you. So what you could do is create an alert, right? So we could pick an alert. We could say, hey, we want to add an alert. And we could say that we want to add alert for a metric with outcome server error, if I remember this correctly, or I don't. Oh, it's outcome like this. No data. Whoops. Create alert. Run a query. Okay, these are the two. So I don't remember the Grafana syntax correctly. So anyways, you could pick that, hey, I would like to make this alert when the server error is greater than 0, right? So whenever you have an exception in your system, please ping me and tell me that there is an error. Who would say that it's a good idea? Like, if there's at least, okay. I'm pretty sure that none of people here in their projects have this special exception like, oh yeah, I mean, it's been here for 10 years. We tried to fix it, but it got worse, so let's not touch it. Don't you see in the stack trace that it's like ignore me exception? Like, don't do it, right? Leave it there. So this is why making it is like above 0 is like ideal, but maybe it's not your case, so you should consider having a rate, let's say, dedicated to your system that, like, if we have, for example, 1 out of 5 requests wrong, then it's already bad. But it's a business decision, right? It's a business decision. Okay, I guess that could conclude my Oh, what is this? This doesn't look good. So what we can see to the left is that we used to have, or maybe Grafana is broken. Let me refresh the page. Again, no. Okay, let's increase the minutes. Okay, so something went wrong. I wonder what it is. And we used to have around 30 milliseconds of latency. Now we have 200. That's quite unfortunate, because I thought that I can already finish this, and I have to now fix this, because over here we can see that we have 5 success, around 5 success. If we go to the last 5 minutes, we'll see that we have 5 success and 0 errors. So there are no more errors, but we have latency. So what did happen that we have this latency? Because if you have an issue, what can often happen, like a bug, is that the users will tell you, hey, I got this stack trace and like there's this problem. So what you can do is then search for the error. Like you can pinpoint this in time, that this error happened at this particular point in time. Oh, with latency, that's not that easy, because I mean, we do see that something happened, but what is the reason for the latency? You will not see that, like a stack trace that, hey, I'm slow. You have to think about like what's going on. So how can we reason about this? So here you can see on the latency in the latency screen that we have those small like dots. So these are actually triangles, whatever. So those are called exemplars. So what is an exemplar? briefly speaking, when a metric is calculated, there's some algorithm behind it, but let's put this aside. If there was a span present, it will be attached to this metric. So you have a correlation between metrics and traces. And the other way, because previously we had logs and traces, now we have metrics and traces. So what we could do is do the following. So I would like to pick a trace view from before the latency got introduced and after the latency got introduced and compare them in the same screen. So let's do it. So I will click here, query this one, and I will copy one from here. There we go. So this is the one from before introducing the latency. Now we will split this and add the second one. Now how do I click refresh here? There we go. Okay, so we have it. So to the left, we can see duration 28 milliseconds, and to the right, we can see duration 182 milliseconds. So something is wrong. So if we look at the thing, is like visually speaking, something is wrong on the water service side. So here we have water service. It was 8 milliseconds, and now the water service is 159 milliseconds. So that most likely is the reason for the whole mess. So let's close this and let's look at this. 159, so we have 50 milliseconds to get the connection and 50 milliseconds to get the query. So that wasn't the case previously. Most likely there's a delay on the database side. So by the way, I didn't show you that previously. Another thing you could do is jump from tracing two metrics, is that for, because spans then themselves have certain attributes, certain tags, you can jump to such metrics that have the same kind of tags and visualize them. So for example, we would like to see the throughput or latency for those specific water service related metrics. And now for that to show anything, I think I had to do something like apply last 5 minutes. No. 50 minutes. Oh, there you go. So this is the increase in latency. So that confirms that for the given trace, we picked one trace that represents the business flow after the latency got introduced. We analyzed that and we think it's related to the database. Now we are looking at the metrics and we can confirm that it's not a singular thing, because it was just one case, we wouldn't have such a growth in the rate of the latency. So evidently there's something problematic here. So how can we also double check this if it's really related to the database? So we have a dedicated dashboard, this one. So that was the water service that seems to be problematic. So let's try to reason about what can be the cause of the fault. So if we look at the basic statistics, we see that everything seems to be flat, like open files, flat, CPU usage, kind of flat. Okay, so we can assume, safely assume that this is what's wrong, that this is not the problem. JVM, flat, seems okay. GC, nothing special. Throughput, flat. Latency, okay, latency is increased, but that's fine because we're on the HTTP side. If the database is stalling, for sure the server-side latency will be bad. Okay, Tomcat we skip. Okay, database, there you go. So here we have the connection latency, and we can see that we used to have 3 milliseconds, now we have around 100 milliseconds. So we have confirmed that this is the reason for the latency. So how can we fix this? Of course, we can file a ticket to the database team, but let's try to do something better than that. So what we can do, of course, I will, since this is a demo, I don't have really time to do things properly. Oh, you never said that in your production systems, right? So what I'm going to do is I will introduce caching. caching because I know that I don't have a lot of data in my database. So what I will do is where I have the water repository. Oh, who put that here? Let me uncomment this. So on the water repository, I will introduce caching. So now whenever the water repository goes to the database, it will go to the database and populate the cache. And since there are like not a lot of entries in the database, quite soon the cache should be filled, and no longer should we actually go to the database. Now, in the proper world, how I would do it is I would run, because I'm using Eureka for service discovery, I would introduce a second instance, and then I would deregister the first instance, etc., etc. I don't have time for that, so I'm going to do kill -9. Kill -9, kill the first one, goodbye, and run the second one. That's how you do it. I mean, it's still better than actually what, of course, you have never done, which is replacing class files in jars on production. All right? Nobody has done this, right? Of course. Okay, so let's wait for this to start. And let's get back to our dashboard. So, oh yes, we're going to see some errors because I closed one of the instances. Now we have to wait for it to come back. So in the meantime, what I can say is the way we could have, let's say, be pinged about the situation again is by introducing certain alerts. So the alerts we could have, let's say the metrics we could have taken into consideration is for sure the connection latency in the on the Hikari side. Another option would be, for example, to create alerts over the metrics coming from Spring Data, because out of the box you get certain metrics and you could, let's say, verify each of those queries if necessary in order to verify whether the connection is correct or if there is no latency on that side. So any second now, we should have the latency drop, assuming that I didn't mess things up, which always happens. Oh, there you go. There you go. Yay, so it worked. So here we can see that I restarted the app. Now we have 5 successes. We've managed to populate the cache, and the latency has dropped significantly, right? Okay, so let's also look at the heat map, if I'm not lying. Yeah, so we had the buckets like from around 134 to 180, and now we're dropping here. And by the way, here, those those pink squares are also exemplars. So you could jump from these metrics to traces from that view as well. Okay, so that concludes the first part. So let us maybe summarize what we did so far. So we had 2 problems. One was a bug, an exception. The other was latency. So thanks to the fact that we had observability, we've managed to look at the metrics and confirm that the bug was there, that we've seen quite a few exceptions. So then we jumped to the logs to confirm that it's not a singular problem. We've seen a lot of errors there. And we picked one of the logs that corresponded to the English breakfast missing exception. From that, we jumped to tracing view, and we dissected the problem and found out that the problem lays with the database. So we added the missing entry, and we did confirm that on the metric side, we see that the problem is gone. Plus, actually, I don't think we did. Let's check if visually that works again. Because you can, oh, there you go, it works. So we did also confirm visually that we can steep the English breakfast tea. And then we saw some latency spike. Using the metrics, we managed to confirm that. Then we went to tracing. We saw 2 traces, one from the history, one from now, the current situation. We compared them and saw that the problem lays with the database, which we confirmed by looking at the metrics of the database. We also confirmed jumping from from tracing to metrics, that the problem is not a singular problem, it's a global problem. And then by introducing caching and doing a poor man's version of zero downtime deployment, we've managed to fix the problem by introducing caching. Okay, so now let's see how on earth was it all possible. So let me look at my notes. So in order for that to happen, you need that you have all this instrumentation. You need certain framework, something that will take care of instrumentation of your code, that will add metrics, that will add spans, and somehow glue them together. However, the problem is there if you have to add it yourself in your business code, because if you have a framework, whatever the framework is, it will not know about your business metrics, because how on earth will it know? You have to do it yourself. So now, let's look at the following thing. In our code, in the controller, water controller, we have something which is called a water fetcher. Water fetcher is an interface that has a method find by size, whatever that is. Now, water fetcher is called over here. So when we get a request find by size, we use the water fetcher. Now, the default implementation of the water fetcher is the repository water fetcher. See, service that will use the Spring Data's water repository to fetch the data from the database. Like very simple stuff. What if you would like now to instrument this with tracing first, then metrics, and then make the call? How can you do it? So to do it, you would have to do the following. First of all, you create a, for example, I mean, there are various ways to do it. But let's say you create another implementation called water service tracing that takes in a tracer. A tracer is a library, like an object that takes care of the life cycle of the span. It can create spans, stop them, tag them, etc. So whenever find by side is called, you would create a span, give it a name, give it a tag, put the span in scope, which means that if, for example, you want to have stuff in the logs, like the tracing information in the logs, you have to put the span in scope. Now you can say that, oh, but didn't you mention that logs are a separate dimension? You have traces, metrics, and logs. Theoretically, yes. So we could have 3 implementations instead of 2. I simplified things. So I merged tracing with logs into one class. But if you wanted to be like really precise, you could have like yet another class, which would make things more complicated. And then you can do various things, like if there was an error, put it on a span. Once you have started a span, eventually you have to stop it. So this is how you instrument your business code just to create a span. Now, metrics. You have exactly the same code, because like we're going to have a function at the end of the day that does call the actual logic. So calling the Spring Data repository. So you have to create a timer, and you have to say, hey, I want to record how much time did this Lambda take to run. And now you need a third class that will glue those together, and that's going to be our new service, at service, so that's going to be a new bean. So it works like this. Whenever you want to find by size, first wrap with tracing, then wrap with metrics, then maybe wrap with logging, and at the end of the day, make the call to the repository. This is how you wrap things, right? And remember, you would have to do it for your business logic every single time if you want to have both, right? So that's quite cumbersome. I can run it again, stop and rerun. And we will see, assuming that I didn't mess things up, that in the logs we should start seeing, here we will have the child span trace ID injected text. Let me find this now. Okay, blah, blah, blah. There you go. So here we have it. Here you will have the span trace ID injected. So that works fine. So we have trace ID, there is a metric, etc. I will skip showing of the metric. So as you can see, you can do it, but there has to be a better way. More like, I'm not saying this is bad, but maybe there's a better way. So what we thought of when we created, so with the release of Micrometer 1.10, we have introduced something which is called the Observation API. So the Observation API looks like this, that you instrument once, and you get multiple benefits out of it. So what you can do is you can create an observation. So you do observation create, not started. You give it a name, right? You give it a contextual name, because the contextual name is a name that is in a certain context. That's why it's contextual name. For example, if you have an HTTP span, typically the span contains the method name, like For example, HTTP post, HTTP get. So it all depends on the context in which you are. As far as metrics are concerned, the name is pretty much fixed. It's not contextual. You can add some low and high cardinality key values. What are those? If you have a low cardinality key value, it means that the value doesn't differ a lot. Because if you put a high cardinality value in your database, let's say, if you put it to your metrics backend, you can blow it up. This is why we have the separation of low and high cardinality key values. You can put an observation in scope, rings a bell, that will inject, for example, for tracing the trace ID. And finally, you can put an error and you can stop it. And you can say, hey, it's a lot of coding. And you can be quite right. This is why we have given an easier way to do it, because you can just call observe. So observation, observe, and that will do all the boilerplate. So what on earth is this? How does it work? Micrometer observation works on the basis of handlers. And let me try to show you one of the handlers. So whenever let's look at the observation handler. Oh, observation handler. So observation handler reacts to events on the observation, like I've started, there was an error, I stopped, I opened the scope, I closed the scope, etc., etc. Now, given those handlers, we have provided some out of the box, like, for example, for tracing, whenever you start, create a timer. Whenever you stop the timer, right? Whenever you create an observation, create a child span. Whenever you stop it, stop the span, right? So instrumentation is one thing, but the features it's providing is a different thing. So for example, if you wanted to now provide logging, you could create your own handler that would log every single time you start and stop an observation. And how can you do it? So here we have a situation like this, that we have this observation and we do the observe, same as before. Now we have introduced something which is called a context. So every time you have an observation, there is a corresponding mutable object map, let's say, that is attached to it, and it's called a observation context, right? So you can extend it, provide your own, let's say, additional things there, like, for example, I'm interested in the size of the water or the class of the water fetcher. So if you do this, then you can provide your own handler that, for example, will log things out. So on start, do this. On error, log this, right? So you can create your own handlers. Now, Jonathan Ivanov has created a handler that is like mind-blowing. I will not show it because it's like too much for me. But he has created a handler that for the given tea service will play MIDI sounds whenever there was a problem or not while brewing the tea. There is a trumpet, there is a like percussion. I'm not joking, it's there in the code. I'm pretty sure you're going to find a more intelligent, I'm not saying that was stupid, but more intelligent way of using the handlers. But yeah, so what I'm just trying to say is here that when you're doing instrumentation, we believe that what you're instrumenting should be very concise, and the features should be pluggable. So this is how it works with Spring Boot, that depending on what you have on the class path, different features will be turned on. If you have Micrometer core on the class path, you're going to get metrics. If you have Micrometer tracing on the class path, you're going to get tracing. You want to use just, for example, OpenTelemetry metrics or tracing API, no problem, create your own handlers. So the way it should behave, or what it should do, is a separate concern. Of course, since this is Micrometer, you don't have to use Spring at all. Right? It's completely Spring agnostic. One more thing, you can also use aspects if necessary. So by using an aspect and registering the observed aspect, you can create your spans and traces and observations, but just by using the aspect. Okay, so we've discussed how you can do observations, how you can instrument your code, what is the context. But now you can say, okay, what if I want to add additional key values here? Or how does it work with, for example, REST template or JDBC, that the tags are added, but I would like to modify how they're added. I would like to provide more of them. So this is something which we call the observation convention. Essentially, it's an interface that we allow the users to implement on their own. So we provide a default implementation that gives the default name, the default contextual name, and the default set of low and high cardinality key values, but you can provide your own. So for example, if you have REST template instrumentation, there is a REST default, I don't remember the name, but default, let's say REST template observation convention that implements the REST template observation convention, and now you can provide your own bean that will either, let's say, extend these key values or provide completely your own. Why does it make sense? Because that way, your code becomes even simpler. Because essentially, that's it. You create the observation, and you call observe. All the information related to tagging, the naming, is pushed to the configuration. Now, who loves writing the docs? Okay, one person. Thank you so much. Person in the back. So I am a fan of the documentation being written by itself. This is why we believe that if you, let's say, follow certain standard of expressing what your observations are, if, for example, you create an enum that implements the given interface, and you tell us, I have one observation, and here you have a Java doc for that. And this is my default observation convention, and these are the low and high cardinality key values I can have, and these are the events I can have. And you describe all of them. I'm not going to go through each of them because it doesn't make sense. But if you provide this description and call a Gradle or Maven Java exec thing, like run this Java main class that we provide in the Micrometer docs generator project, out of the box, we will generate the docs for your observation out of the box. So if you go here, I've already run this, and you will see or not, let me do this. Okay, can you actually see this? I guess more or less. So this is these are the observation conventions that we found. This is the list of all the metrics together with the low and high cardinality key values. All of them are taken from sources, so no longer do you have to do it yourself. If you don't like the template we've provided, you can provide your own. That's not a problem. It's completely pluggable. And this is the same thing for spans. So whenever you change your code, the docs will change as well. So let me run the last thing, because I would like to have like 5 minutes for questions, because maybe you do have questions. So let me run the last example. So water service observability with convention. Now let me just remove the service from here. Oops. This one and this one. That's done. Now where is the configuration? Water observability configuration. Yeah, and let's add the handler. And let's rerun this. So we would start seeing the observability using the observation convention. There are two things that I can also mention. If you would like to completely change the way, for example, the observation names are set, you can use something which is called an observation filter. So for example, you say, I want to rename the given observation, or I want to add a default key value like environment dev. That's how you do it. Or you want to say, hey, I have certain observations that I want to ignore, then you use an observation predicate. Now let's look at what we have here. Water service observability. No, that's this one. With convention. This will have a trace ID. Hopefully that's going to work. So first of all, you can see the handler that is now like spamming me with text that I didn't want. And here you have this will have a trace ID, right? So just by doing a very short line of code, this is the whole code you need to actually do instrumentation. Okay, so let's sum up this part and then let's go to questions. So I've managed to show you is how you can do observability using micrometer observation. First, I've shown you how what problem are we trying to solve is doing manual instrumentation. Regardless of what framework you're using, you will have the same problem, unless you're using aspects. But sometimes you don't want to use aspects, right? Because that way you have to manually instrument the code using all the dimensions you want, like metrics, tracing, and logging. And then I've shown you how you can use micrometer observation for that. I've shown you what the handlers are. And finally, I've shown you how you can use observation documentation in order to document your code automatically and generate the docs out of your code. Okay, so that's it from my side. So I guess it's time for questions, and I will put the live coding ADoc if readme files. Okay, so are there any questions? Don't be shy. No questions. So either I did a fabulous job about explaining things, or you're shy, or quite the contrary as far as my excellence in explaining things is concerned. So no questions? Okay, there's one question. Thank you so much for asking this question.
Hello. Thank you for your presentation. Question from my side is, you showed for doing the tracing, we need to create the span, close the span, and so on. My question is, if we want a simpler way, so I want tracing throughout my whole application, and I don't want to be creating spans everywhere, closing the spans, is there a simpler way to do it or not?
I don't fully understand the question. So you say you have your own app and you don't want to create the spans?
We have to create the spans.
You have to create the spans.
As you showed there.
Yeah.
Right?
And is there a simpler way than what I've
Exactly.
shown? So the only thing that comes to my mind is aspects. So you would create an aspect around the method that essentially would do all the work that I've shown you. So this one, where is this? This work would be done by aspects. So essentially, this is the actual logic, let's say, more or less. So you would have an aspect that does pretty much it, like wraps the whole thing around. This whole code, except for this line, would be done by an aspect, and that would delegate to the proceeding join point or something like this. I don't see any easier way, unless you create some sort of a framework that hides this away, right, from you.
All right. Okay. Thank you.
Thank you. Any more questions? Oh, there's a question over there.
Hello.
Hello.
Thank you for the presentation. Do you have this code available on your GitHub or on your website?
Can you speak a little bit louder, please?
Do you have this code available on your GitHub?
Do I have this code available on Twitter? Yeah, that's a very good question. If I remember correctly, it's Jonathan Ivanov T House.
All right, thank you.
Thanks for reminding me. Code. There you go. The patch on production. Okay. Any more questions? There's a question here.
Hi. So in the beginning of the presentation, you mentioned distributed tracing. How would you handle like latencies between services that are deployed in different time zones, for example? Is there a way to like measure latencies between those two services, taking into account they are in different time zones, or?
So I don't think that's a problem. I'm not like an expert in internals of how the backends support that, but I'm pretty sure that because I used to be working closer to Zipkin project, which is the latency visualization tool, that had the ability to do some skewing and stuff like that to adjusting clocks. So I'm pretty sure that like the time zones are completely not a problem, because most likely you just, in terms of a span, you send the duration. So that shouldn't be a problem. I have never heard of that being a problem in any actual project.
Okay, thank you.
Thanks. Any more questions? So, because we have 10 seconds, so last question. Okay, so no more questions. So thank you very much.